Hello everyone, I'm Muskan from BSC Chemistry Honors first year. Today I'm going to give presentation on Fajan's rule. So let's start.
So, if we want to know about the covalent character in an ionic bond, I want to give you a brief introduction about ionic or electrovalent bond. Electrovalent bonds are formed by electrostatic attraction between two oppositely charged ions, and these oppositely charged ions are generated by transfer of electron from one ion to other ion, and the ion which gives its electron is known as cation and it has positive charge, while the ion which accepts electron is negatively charged and is known as anion. So, what are the conditions required to form an ionic bond? Ionic bonds are formed when the electronegativity difference between the two elements is high. Second, cations should have low ionization energy, means they can easily give up their outermost shell electron or valence electrons. Third, anions should have high electron affinity, means anions should be able to accept electron easily. Fourth, ionic bond has high lattice energy. Lattice energy is the amount of energy required to break 1 mole of bond into its gaseous state. So, if the energy is high, the bond will be stronger, and ionic bonds are stronger in nature. And the lattice energy depends upon the charge to size ratio of the ion. But according to Fajan's rule, no bond is 100% ionic in nature. It has some covalent character in it. How? If a cation is close to an anion, it attracts its outermost shell electron. So the anion is not in its perfect shape while it gets distorted, and this is known as polarized electron cloud of anion. So when an anion is distorted, when the electron cloud of anion is distorted or pulled by cation, there is development of polarization in anion, and this distortion and polarization is responsible for development of covalent character. So, covalent character of a bond increases with increase in polarization or distortion of electron cloud of anion, and this distortion or the development of polarization depends on various factors. First is size of cation. Smaller the size of cation, more is covalent character. Because the small size of cation makes it highly polarizing and more effective in distorting electron cloud of anion. So, if there is decrease in the size of cation, there will be increase in covalent character. For example, in alkali family, lithium ion has smallest size and cesium has maximum size. So there is increase in the size of cation down the group. The size is smallest for lithium. So the covalent character will be highest for lithium, and there is decrease in the covalent character when we go down in the group. Then next is size of anion. Bigger the size of anion means an anion has bigger electron cloud. It is higher possibility that its electron cloud will be distorted or get polarized. So the covalent character increases with increase in the size of anion. For example, if we take sodium fluoride, sodium chloride, sodium bromide and sodium iodide, among them sodium, that is cation, is common, but the size of anion is increasing and the iodide ion has maximum size. So, the covalent character will be maximum in NaI and will be smallest in or minimum in. The covalent character will be minimum in sodium fluoride. Then, third factor is charge on cation. Higher the charge on cation, more polarization it will cause to anion. For example, Na plus Mg plus 2 and in Al plus 3. The difference in size is not so much high, but the charge is maximum on aluminium. Maximum charge is Al plus 3, so it will have more covalent character. Next factor is charge on anion. Similar to cation, when the charge on anion increases, its covalent character it also increases. Fifth factor is very important and it is pseudo-inert gas configuration of cation. When the cation does not have a noble gas configuration, the covalent character of an ionic bond will be large. So first we will try to know what is noble gas configuration and what is pseudo-noble gas configuration. Noble gas configuration is Ns2Np6 or 8 electrons in the outermost shell, while pseudo-noble gas configuration is Ns2Np6 and D10 or 18 electrons in the outermost shell. So, how the noble gas configuration or pseudo-noble gas configuration will affect the covalent character of an ionic bond. So, first I will give you a hint about what is shielding effect. Shielding effect is the effect by the inner shell electrons on the outer shell or on the valence shell electron. These two electrons, the valence shell electron and inner shell electrons, repel each other because they have same charge, so there is repulsion between them. And the outermost shell electron or the valence shell electron has attraction force with there is attraction between nucleus and outermost or valence shell electrons. So due to the repulsion of these inner shell electrons, the attraction field by these outermost shell electrons is decreased. Okay, because of this repulsion, the attraction force, these electrons will feel smaller attraction by the nucleus. So these inner shell electrons act as shield and it is known as shielding effect. And this effect is more pronounced by s orbital electrons than p, d and smallest for f. So in case of noble gas configuration, the electrons are in n and s and p shell. So they will cause strong shielding effect. Or you may say that noble gas configuration has closed outermost shell and it shields the nuclear charge more effectively. Thus, a cation with noble gas configuration has less power to polarize anion because these electron has s and p electrons has more shielding effect. So there is smaller effective nuclear charge. While in case of pseudo-noble gas configuration, the outermost shell, the electrons in outermost shell in the d orbital, the electrons are in d orbital, and the shielding effect is very weak for d orbital electrons. So they will cause smaller shielding effect. So the effective nuclear charge is high in comparison to s shielding caused by s and p electrons. So when the effective nuclear charge is high of the cation, then it will cause high polarization to the anion and there will be high covalent character. So the covalent character will be high when a cation has pseudo-noble gas configuration instead of noble gas configuration. For example, copper plus. Copper has 29 atomic number, means it has 29 electrons. So for copper plus, we will try to find out electronic configuration. It is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So these this is the pseudo noble gas. It has pseudo noble gas configuration, means it will have covalent character or higher effective nuclear charge. Let's take another example. In case of zinc plus 2 and magnesium plus 2, both of them have same charges, plus 2, and they also have almost similar size. Then between two of them, which will have higher covalent character. So we will try to find out their electronic configuration, and for Zn plus 2, it has pseudo noble gas configuration, that is 3s2, 3p6 and 3d10. For maximum principal quantum number, this is the configuration, electron configuration in the orbitals. While magnesium plus 2 has 1s2, 2s2, 2p6 and it is noble gas configuration. So it means that these electrons have very stronger shielding effect. They will effectively reduce the nuclear charge, and the effective nuclear charge is very small as compared to Zn plus 2. So Zn plus 2 will have higher effective nuclear charge as compared to magnesium plus 2. So when higher effective nuclear charge means nuclear charge on cation means it will cause more polarization in anion and it has more covalent character. So now we will take few applications of Fajan's rule. So first we will remember that when polarization increases, covalent character increases and melting point and boiling point decreases, because for ionic bond melting and boiling points are high. So when there is increase in covalent character in ionic bond, there will be decrease in melting and boiling point, and solubility in polar solvents will also decrease when there is increase in covalent character. So if you remember this equation, we can solve lots of problems. So first is, among sodium bromide, magnesium bromide and aluminum bromide, which will have highest melting point? So all of them have same anion. So first we will try to find out the charge on cations. Na plus Mg plus 2 and Al plus 3. So Al will have maximum charge on cation. So high charge means it will have more covalent character. More covalent character means there will be decrease in melting point. It will have low melting point. So among them, NaBr will have highest melting point. Next is, among NaF, NaCl, NaBr and NaI, which will have lowest melting point? So they have same cation, but anion is different, and there is increase in the size of anion when we go from NaF to NaI. I has maximum size, so it will have more covalent character. More covalent character means it will have lowest melting point. NaI will have lowest melting point. Next question is, LiCl is soluble in alcohol but NaCl is not. Why? So we will have anion is common in both of them. So cation is Li plus and Na plus. Li plus has smaller size as compared to Na plus. Means when cation is small, then covalent character will be high in the ionic bond. Means LiCl will have more covalent character as compared to NaCl. More covalent character means it will be soluble in non-polar solvents easily. So LiCl will be more soluble in alcohol, but NaCl, which have less covalent character, will not soluble in alcohol. Next question is, which has more covalent character? First is CuCl and NaCl. Second is Na2 minus and NO3 minus. So in the first example, we have Cu plus, which has pseudo noble gas configuration, while Na plus has noble gas configuration, means Cu plus has more covalent character. Next is NO2 minus and NO3 minus. NO3 minus, the size of NO3 minus is high, and because it has one additional oxygen atom, so its size is high, its size is big. So when the size of anion is big, means it has more covalent character. Next, what should be the melting point order of LiCl, NaCl, KCl, RbCl and CsCl? So there is increase in the size of cation when we go down to the group, means there is decrease in covalent character. So LiCl should have smallest melting point and CsCl should have maximum melting point, but the actual order is NaCl has maximum melting point, LiCl has minimum. LiCl has the melting point according to the Fajan's rule, but NaCl and other alkali halides are not following Fajan's rule, and there is successive decrease in the melting point when we go from NaCl to CsCl, because there is decrease in lattice energy value. Lattice energy depends on charge to size ratio, and charge is same for all the cations, but the size is maximum for cesium. So this ratio will be smallest for cesium chloride and highest for NaCl, means NaCl has highest lattice energy value and cesium chloride has lowest. So when lattice energy is high, means high amount of energy is required to melt these salt into their gaseous states. So NaCl has highest and melting point and cesium chloride is lowest if we forget about LiCl. So according to this, Fajan's rule is not able to explain melting point variation in alkali metal halides. It is an exception. So you have to remember it. So that's it.